Hello everyone and welcome to week 7 of the free online pre-calc / trigonometry course. Today we're going to be covering solving trig functions. So basically last week we've already talked about the unit circle for 2 weeks now. Last week we talked about graphing trig functions. But today we're going to be talking about solving trig functions, which is actually easier. There's less stuff to memorize. Now I will admit I'm assuming that you have at least a good enough knowledge of the unit circle by today that this is going to start to get easier than, for instance, a couple weeks ago. But even if you're not great, I include a unit circle in this packet on the second page. And so you can use that as you're going through either the problems today or even on the homework when you're by yourself. So first we need to talk about how we're solving trig functions. We're going to be solving trig functions today in the same way you would solve literally anything else in math, any equation since Algebra 1, and that is we're going to start off by actually getting the trig function by itself. For instance, that could be getting the sine x by itself, the cosine, the tangent, whatever. Then you are going to take the arc trig or inverse trig. I'll call it arc trig. No, I'll call it inverse trig. I take it back. They mean the same thing. I just feel like it's going to be easier for you guys to know what inverse trig is. An example would be if I had, for instance, sine x equals 1, and then step 2 is like saying x equals the arc sine of 1. That's what I mean by inverse trig. And then you're going to need to use the unit circle to solve, which again I include on the next page. So for instance, I look at this example I just made up. Where on the unit circle does the sine equal 1? And the answer is at x equals pi over 2. And the reason I know that is because the sine of pi over 2 is 1. So that's why pi over 2 is the answer. Don't worry, we're going to get better at this, but this is just a short example. Now, we need to also remember that there are certain quadrants who are positive and negative. So let's see who remembers. What is positive in the top right quadrant? Sine, cosine, or tangent? The correct answer is A for all. All of them, sine, cosine, and tangent, are all positive in quadrant 1, the top right. Which one's positive in the top left, quadrant 2? That's going to be sine. Next, quadrant 3. That's going to be tangent. And then does anyone know quadrant 4? Yeah, it's obviously the only one left. It's cosine. And the way that I usually tell people to remember, it's a little acronym that I didn't make this up, but someone did, and I like it. You need to remember A, S, T, C. So what I like to tell students to remember is all students take calculus. And maybe not all students take calculus, but if they did, then it'd be a great way to remember this unit circle fact. The other thing I want to say for what we're doing today, we're going to be dealing with radians only. In other words, no more degrees. We did the same thing last week, but yeah, we're only doing radians today. And you may be wondering, why is that? Well, it's basically because I've only ever done these problems with radians in school, which means that you'll probably do the same thing when you get that far. So here's the first thing we're going to do. We have some just quick examples that I'm going to show you how to do. Again, this is assuming you know the unit circle, so maybe you could think of this as a warm-up. So for instance, for this first one, I'm going to say x equals the arc sine of 1/2. And then I have to ask myself, where does sine equal 1/2? Does anyone know? The correct answer is pi over 6 in radians. But there's also another answer. There's another value. It's in quadrant 2, because that's where sine is positive. And so the other quadrant, or the other angle it's positive, is 5 pi over 6. So in other words, 2 solutions. Most of the time you're going to have 2 solutions. Sometimes you just have 1 solution. We'll talk about that later. Next one, if you want to solve for cosine x equals root 2 over 2, that means you're going to say x equals the arc cosine or inverse cosine. Again, means the same thing, of root 2 over 2. And where does cosine equal root 2 over 2? That's going to be either at pi over 4, or where else is cosine positive? Looks like quadrant 4. What's the quadrant 4 version of pi over 4? That is 7 pi over 4. And again, you can use a unit circle to help you. And then 2 more to go. Tangent x equals negative root 3. Again, same idea. X equals the inverse tangent of negative root 3. Now I have to ask myself, where am I going to do this? And let me be more specific. When I say negative root 3, I know it's got to be in either quadrant 2 or quadrant 4, because that's where tangent's negative, because tangent's only positive in the top right and the bottom left. So in other words, I need quadrants 2 and 4 where it equals root 3. And if you look at a unit circle, that's going to give you 2 pi over 3, and then the other one is 5 pi over 3. Okay, and then just one more for this first page. Cosine x equals negative 1. Again, I take the arc cosine of both sides. Arc cosine of negative 1. Where does cosine equal negative 1? That's going to be at this point right there, and that happens to be pi. So the answer is pi, and there are no other values. Why not? Because there's only one. It's not even a quadrant. It's like kind of in between the quadrants. And so whenever you're in between the quadrants, like for instance on the line, either horizontally or vertically, that's when you're going to have one answer in either of those cases. Any questions on anything I just said? Okay. Now on the next page, I again give you a unit circle, very handy. You'll notice this one has both the degrees and the radians, but again, we're just going to be using radians. And the way you read this, just so you know, the way you read this is that for each of these, the first number is the cosine value, the second number is the sine value, and the third value is the tangent value. So in other words, if I ask you what is the sine of 5 pi over 6, this angle right here, you would say it's positive 1/2, because that's the y value, and that's how you follow the chart. Hopefully that makes sense. If it doesn't, please say something right now. If not, I'll assume you get it. You may be wondering, why is the tangent undefined here? And it's actually undefined here at the bottom as well. Again, we kind of talked about this before. Basically, the reason why is because tangent is equal to sine over cosine. And at that point, sine is like 1 and cosine 0. And you can't divide by 0. So that's why it's undefined at those points. And again, I recommend just memorizing that fact. You don't have to derive it each time. Any questions? Okay then. With that, we're going to be going on to the first few problems here. By the way, you'll notice that for each of these problems, I just want to solve on the interval from 0 to 2 pi. Why does 0 get the closed bracket and 2 pi gets the open parenthesis? The reason why is because, remember, 0 and 2 pi are the same point. If I go back up to my unit circle, 0 and 2 pi are the exact same point. So I don't want to double count 2 pi or 0. So in other words, I'm basically going all the way up to like 359 degrees, which is why it gets the parenthesis and not the square bracket. If that's confusing to you, basically, to put it simply, just stop between 0 and 2 pi, and if you get an answer of 2 pi, don't write 2 pi. I repeat, do not write 2 pi if your answer is 2 pi. That's all I'm saying. So anyways, for these first couple, I'm going to get them started. For instance, if I want to solve for sine x, well, 2 sine x equals root 3, the first thing I got to do is get sine x by itself. That means I'm dividing both sides by 2. So in other words, sine x equals root 3 over 2. And then if I want to solve this, I take the arc sine of both sides. The arc sine of root 3 over 2. I get two answers for this because there's two quadrants, quadrant 1 and quadrant 2, where that's going to be positive root 3 over 2. And our answer is x equals pi over 3 and 2 pi over 3. Because that's where it's positive, and that's where the sine equals root 3 over 2. Any questions on that first one? Okay then, let's continue. Next, number 2. 3 tangent x plus 3 equals 0. Again, first thing I got to do is solve for tangent x. How do I do that? Well, first I got to get rid of this plus 3. So minus 3 to both sides. So now 3 tangent x equals negative 3. And now hopefully you see this. You just got to divide both sides by 3. So it looks like tangent x equals negative 3 divided by 3, which is just negative 1. Okay, now I have to ask myself, where does tangent equal negative 1? For this one, I'll go back up to my unit circle. So I'm looking on the unit circle. I'm looking for it equals negative 1 for tangent. It looks like here at 3 pi over 4, and it also looks like down here at 7 pi over 4. Those are my two answers. X equals 3 pi over 4 and 7 pi over 4. Okay? And keep in mind, why'd I go to those quadrants? Because that's where it was negative. And so we really have to remember where the quadrants are positive and negative for sine, cosine, and tangent. Any questions on number 2? Okay, next, number 3. We have root 2 cosine x equals 0. So for this one, I just divide both sides by root 2. So cosine x equals 0 divided by root 2. And this is confusing, right? But hopefully you know that this is just 0 because 0 divided by anything is just 0. Remember, this is not undefined. Undefined is when the 0 is in the denominator. This is just 0 because it's in the numerator. And now where does x, or should I say, where does the cosine, inverse cosine, equal 0? That is going to be only at, well actually that's a lie. It's at two numbers. The first number is at pi over 2, and the second is at 3 pi over 2. So that is where cosine is equal to 0 at those two values. That's it. Again, if I go back up to my unit circle, I see that that happens right here at pi over 2 where the cosine 0, and down here where the cosine is 0. I'm going to erase some of these points because it's getting too cluttered on my unit circle. Okay, that's better. Next, we have number 4. Tangent x is undefined. Hopefully you know what this is because we actually kind of talked about it already. Can anyone tell me what the answer is? The correct answer is x equals pi over 2 and 3 pi over 2. And again, the reason why is because if you look at the unit circle, that is where tangent is undefined. You'll also notice that answers 3 and 4, or questions 3 and 4, had the exact same answer. I mean, that's a coincidence, but notice how you can have wildly different answers. Like, for instance, tangent x was undefined, cosine x was 0. So it really helps if you know your unit circle, because it's not like you're going to use intuition a lot of times. A lot of times it's just memorization, to be perfectly honest. And now for numbers 5 and 6, I'm going to tell you, you probably need more space than I gave you. That's my bad. But either way, we're going to solve them now. So sine squared x equals 3/4. The secret here is that you're going to have to take the square root of both sides. So what that means is sine x equals, remember, whenever you take a square root, it's plus or minus. So plus or minus 3/4. I'm going to be simplifying this because I know that square root of 3/4 is the same thing as root 3 over root 4. And I know that the square root of 4 is just equal to 2. So just like that, I got sine x equals plus or minus root 3 over 2. This is a great start. But now, how do I deal with a plus or minus? It's simple. Just write it out twice. In other words, sine x equals root 3 over 2. And then sine x equals negative root 3 over 2. That's going to be how we do it. We're going to solve it twice. And as soon as I see this is plus or minus, I already know it's going to be all 4 quadrants because it's all the positive and the negative values. And I also know that it's equal to root 3 over 2 when it's in like the pi over 3 family. What do I mean by the pi over 3 family? Let me go back to my unit circle. I'm saying it's root 3 over 2 for sine at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. That's what I mean by the pi over 3 family. It's all of those. So in other words, I'm just going to write that out. X equals pi over 3, comma, 2 pi over 3, comma, 4 pi over 3, comma, 5 pi over 3. And will I always get 4 answers when I have a square root? Not always, but a lot of times I will. And now we have number 6, last one on this page. Again, write small. So for this one, 2 cosine squared x minus 1 equals 0. Hopefully you recognize, first thing I got to do is add 1 to each side. So 2 cosine squared x equals 1. Divide by 2 then. So cosine squared x equals 1/2. And now I got to take the square root of both sides again. And remember the plus or minus. So for instance, one answer I get, well, hold on a second. This isn't very good for us because this has a square root in the denominator. Let me explain. Even if I write this as root 1 over root 2, which I can do that, absolutely. and even the numerator is just 1, right? Because the square root of 1 is just 1. I can't have a square root in the denominator. So what do? I rationalize it. What does rationalizing mean? It means I'm going to multiply the numerator and denominator by root 2 over 2. Root 2 over root 2. So for the numerator, I have 1 times square root of 2, which is square root of 2. In the denominator, root 2 times root 2 is just 2. There we go. And this looks a lot more familiar to me because I know that cosine is root 2 over 2 in the pi over 4 family. Anyway, since it was squared, I do need to say plus or minus. So cosine x equals root 2 over 2, and cosine x equals negative root 2 over 2. And once again, it's going to be all 4 quadrants here because it's positive and negative. So in other words, I'm going to get all 4 answers. X equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And once again, I got those by using my unit circle in my head. Any questions on that page? I've got to tell you, it only gets worse from here. So the next one will be worse, I promise. So far, I would say it has not been that bad today. It's not been that bad. Now, let me show you what happens when we have something in the parentheses. Like, for instance, this is the function sine of 2x. You'll notice it looks very similar to the format of sine x. In other words, it's the same shape. Truth be told, it's just more scrunched together. I think that's the right word. Now, I'm not going to tell you to graph it because that was last week, number 1. And number 2, I graphed it right here in front of us. But basically, if I want to set this equal to 0 and solve, how many solutions do I have? Let's count. 1, 2, 3, 4, 5. And I'm not just saying 0 to 2 pi. I'm saying like all the solutions from negative infinity to positive infinity, right? In other words, I've got infinitely many solutions. Oh, and by the way, solutions are where you intersect with the x-axis. That's why I'm circling these points. It's where it equals 0. And again, this sine curve is going to go on forever, so I'm going to have infinitely many solutions. So then how am I going to write this? How am I going to write it when I have infinitely many solutions? Let me show you. So first of all, here's sine 2x equals 0. First thing I do, take the arc sine of both sides. 2x is equal to the arc sine of 0. And I know where it equals 0. It's actually at 2 points. The first one is 2x equals 0, and the second point is 2x equals pi. That's where sine is equal to 0. Now, the thing is here that I need to remember that, well, I'm not sure if you know this or not, but I'm going to tell you anyways. Since sine, cosine, and tangent all repeat on an interval of 2 pi, in other words, if you look at 0, that's the same thing as 2 pi, that's the same thing as 4 pi, that's the same thing as 6 pi, that's the same thing as, I can play this game for a while. So then the way I account for every solution in an easy shorthand notation is I'm going to write this. 0 plus 2n pi, where n is a constant. In other words, n can be 0, n can be 1, n can be 2, n can be 3. It can even be the negative values as well. But basically, n is like every positive and negative integer and 0. So here's what I would say, for instance. At this point, I would then divide both sides by 2 to solve for x. So x equals 0 over 2 plus 2n pi over 2. The 2's cancel there, and the 0 just goes away because it's 0. So it looks like my answer is x equals n times pi. Let me be very clear here what I'm saying. If n is an integer, I'm saying x equals, first if n is 0, then it's 0 pi, then it's 1 pi, then it's 2 pi, then it's 3 pi, and you can play this game for a very long time, and again, you got the negative values as well. But if you just want to write the answer very nicely, you would just write this, x equals n pi. That's what I'm going to be doing today with you guys. Oh, and we still have another solution here. Remember, 2x equals pi? We had to solve that one too. So now I have to remember that this is pi plus 2n pi, same as before. And now I got to say, well, divide everything by 2. So now I get x equals pi divided by 2 plus 2n pi over 2. Again, the 2's cancel. It looks like I get x equals pi over 2 plus n pi. There's my answer in just a standard form, whatever you want to call it. And then if I actually plug in values for n, you'll see I get x equals first pi over 2. Then when it's 1, pi over 2 plus pi with a common denominator of 2 is really the same thing as pi over 2 plus 2 pi over 2. So in other words, that's going to be 3 pi over 2. And if I just list out the next few numbers will be 5 pi over 2, then 7 pi over 2. And again, it's all the negative numbers as well, like for instance, negative pi over 2 and so on. And why am I not circling this as my final answer, the x's? Is because I'm circling the version with n in it because n covers every possible solution. That's why I'm writing it this way. And again, maybe it doesn't make perfect sense yet, but I think once we do a few examples, you'll at least start to get the notation, even if you don't understand what you're doing. So, any questions on that page? Okay. One thing I do want to tell you, just so we can map out the rest of today, we're going to be doing like a bunch of problems like the one I just did on, and you can see here, I have it from the interval from negative infinity to positive infinity. Remember, the first few problems we did, those were just 0 to 2 pi, right? But these are from negative infinity to positive infinity. This is when I write plus 2n pi because of that fact. And then at the very end of this lesson, we're going to be doing the exact same thing with these multiple answers with like the 3x and the 6x, whatever. But we're also going to be answering on the interval from 0 to 2 pi, and those are going to be the worst problems for today. So for this first one here, 4 cosine x equals 2. The good news is this is very similar to one we already answered on like the first set of problems we did. Let me explain. First thing I do is divide both sides by 4. So cosine x equals 2/4 is the same thing as 1/2. And then I just have to ask myself, well, where does cosine x equal 1/2? The answer is x equals pi over 3 plus 2n pi. Okay, that's one of my answers. But again, there's another quadrant where cosine's positive. It's quadrant 4. So in other words, quadrant 4 for pi over 3 is really going to be 5 pi over 3. Again, consult your unit circle if you have questions. And then plus 2n pi, because just add 2n pi to all of these answers. That's basically what I'm saying. And that's it for number 7. We're done. We don't have to do any more work than this. Any questions there? Okay, good. Next we have tangent. Tangent has a special property that I'm going to be explaining, but here's the problem. So first thing I need to do is divide both sides by -1 to get rid of the negative sign. So that means tangent of 3x equals -1. Now, here's what I'm going to say. Take the arctangent of both sides, so 3x equals, when does tangent equal -1? It's at two numbers. The first one is pi over 4. Well, not pi over 4, because that would be +1. If I want -1, I need to be in quadrant 2. So in other words, 3 pi over 4, that's quadrant 2. And the other solution is, and give yourself some space, because we're going to still write something here, but 3x equals, where else is it negative? Quadrant 4? 7 pi over 4. Okay, I didn't give myself enough room for that, but that's okay. So don't forget you need to add the plus 2n pi, because this is, well, negative infinity to positive infinity as our interval. And then I'm going to do the same thing here for the other one, plus 2n pi. And I know I'm off the page, but whatever, I think you get the idea. But I'm not done yet. I still need to solve for x. That means dividing both sides by 3. So for instance, on the left, dividing both sides by 3, I'm going to get x equals 3 pi over 4 divided by 3. The 3's cancel, and so you just get pi over 4. And if you didn't know that, you could also say it's 3 pi over 12, which will reduce to pi over 4 anyway. So even if you missed the canceling out, doesn't matter. And then I have to say plus 2/3 n pi. Okay? Now, here's one solution right here. Okay? But now for the other solution, same idea. Divide both sides by 3. 7 pi over 4 divided by 3 is 7 pi over 12. And then plus, again, same thing, 2/3 n pi. I know I barely squeezed it in here, but hopefully you see that. Any questions on that one? We're done, by the way. This is it. Okay. One more thing I do want to say. Tangent is a special case. Tangent's a special case because tangent is the only one out of sine, cosine, and tangent where instead of writing x equals pi over 4 plus 2n pi and x equals 7 pi over 4 plus 2n pi, I mean, I guess this was, hold on, this was 3 pi over 4. I apologize. Instead of writing this, for tangent only, I can get rid of the second one and just get rid of that 2. In other words, x equals 3 pi over 4 plus n pi. This is the only one that works for. If you're curious as to why that works, it's because it's perfectly symmetrical. In other words, if I write out the first few values for n, like for instance, here's when n equals, well, I guess 0. And then when I add pi to that, and when I add 1 pi, I'm technically adding 4 pi over 4 to get the common denominator. I get 7 pi over 4, which was the same one I crossed out a minute ago. See how that's 7 pi over 4 right there? So that's only going to happen for tangent, at least consistently. So another answer we could have said, because this was technically 3x, another answer we could have said was x equals pi over 4 plus 1/3 n pi. And this would be correct as well, and you don't need the second answer. Do I recommend you know that? Probably not. It's a little too advanced for the summer. But it is true. If you see me put that in the answer key, I forget what I did or not, to be completely honest. But I think, if I remember correctly, I put this solution for sure. I definitely put this solution, like both solutions. So at least look out for that. Any questions on number 8? Okay, next, number 9. Number 9, we have 4 sine of 6x equals 2 root 3. So again, first thing I'm going to do, solve for sine, divide both sides by 4. That means sine of 6x is equal to 2 divided by 4 is 1/2. So it's really like 1/2 root 3, which of course I'm not going to write it like 1/2 root 3. I'm going to write it like root 3 over 2 because I am very familiar with root 3 over 2. I know that when I take the arc sine of both sides, I'm going to get 6x equals pi over 3 plus 2n pi. And then another solution I get is 6x equals, we're also looking at quadrant 2 because that's where sine is positive. So quadrant 2 is going to be 2 pi over 3. And again, plus 2n pi. And again, this one does not have the special case. I have to write both of these. And now I just divide both sides by 6. Pi over 3 divided by 6, that's pi over 18. I'm doing that by multiplying the 3 and the 6 for pi over 18. And then 2n pi divided by 6, well, that's just going to reduce to n pi over 3 now. And so there's one of our solutions. And then the other solution dividing by 6, let's see, it's 2 pi over 18, which actually reduces to pi over 9. I'll write pi over 9 instead. That's how it reduces. And then plus, same thing, the 2 and the 6 will reduce to n pi over 3. And there's my final answer for that one. Any questions? Okay. Now, let's see if you can... Well, I'm going to ask you to do number 10 by yourself, but I just want to warn you, what do we do with the x over 2? I just want to address this now. Eventually, you're going to get to the point where you say x over 2 equals blah, 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 plus 2n pi, okay? My advice to you is, if you want to get rid of that 2, instead of dividing both sides by 2, you're going to have to multiply both sides by 2. So that's the secret to this problem. I'm going to give you a minute to solve it by yourself, and then we will reconvene and I'll explain the solution. So go ahead. And I'm going to say time's up. If you're not finished, it's completely fine. Of course, if you're watching the recording, you just unpause the video. Anyways, here's how we solve this one. First, minus 5 root 2 from both sides. So that's going to be 10 sine of x over 2 is equal to negative 5 root 2. And then you have to divide both sides by 10. So you're going to get sine of x over 2 equals negative root 2 divided by 2. Why? Because 5 divided by 10 leaves you with the 2 in the denominator. So negative root 2 over 2. I know negative root 2 over 2 is the pi over 4 family. And since it's negative, I'm going to be in quadrants 3 and quadrant 4. So that means x over 2 is equal to 5 pi over 4 plus 2n pi. And I'm also going to get x over 2 equals 7 pi over 4 plus 2n pi. And like I said before, the secret to this problem, multiply both sides by 2 now. For this one, you're going to get x equals 5 pi over 2 now. Why? Because 5 pi over 4 times 2 leaves you with a 2 in the denominator, so that's why that makes sense. And then plus 2n pi becomes plus 4n pi. So there's one answer. And the other answer, same idea, multiply everything by 2. X is going to be 7 pi over 2 plus 4n pi. And there we go, there's our solutions. Did that make sense? Okay, I'll take silence as a yes. Everything makes sense. Good. Next, for numbers 11 and 12. 11 actually isn't crazy. 12 is crazy in the sense that you're going to need a lot of space to write your work. So I'm just warning you right now. 11's not terrible. You're going to probably need extra space for number 12. I didn't plan this great. But anyways, let's do number 11. Cosine squared of 8x equals 1. I think you know what to do. Maybe you don't. But it's going to be square root of both sides. And don't forget to say it's plus or minus. So in other words, cosine of 8x equals 1. And cosine of 8x equals negative 1. And now what I'm going to say is take the arc cosine of both sides. So 8x equals, where does cosine equal 1? That's going to be, of course, at 0 plus 2n pi. And then the other answer is at 8x equals pi plus 2n pi. Because that's where cosine equals negative 1 at pi. Now I just have to divide both sides by 8, and I'll get my two answers. It looks like x is going to be, well, 0 divided by 8, that 0 is just going to go away. And then 2n pi divided by 8, that's going to be n pi over 4. And then for the other one, it's going to be x equals pi over 8 plus 2n pi over 8, which is n pi over 4. So there's my two solutions for number 11. And then for the last one, here on this page, number 12, I'm just going to warn you now, it's a lot. And even though it's tangent, I'm just not going to do the special case. I think the special case might be a little too advanced for today, so I'm just going to ignore it. But first thing I do is I divide both sides by 3. That's the easy part, obviously. So I get tangent squared of x over 3 equals 1/3. Next thing I'm going to do, take the square root of both sides. Now, I don't like the square root of 3 in the denominator. So in other words, I got to figure out how to get rid of that. First thing I do is I break it up into root 1 over root 3. I also remember square root of 1 is just 1. And root 3 is still a problem. So then I multiply by root 3 over root 3 to rationalize it. In the numerator, I'm going to have 1 times root 3, which is root 3. And in the denominator, root 3 times root 3 is just 3. There we go. Don't forget this is plus or minus, which is why this takes up so much space. So now I've got basically two answers here. Tangent of x over 3 equals root 3 over 3. And then I'm going to have tangent of x over 3 equals negative root 3 over 3. This one's going to have 4 answers, just so you know. The first answer is to say x over 3 is equal to, where does tangent equal root 3 over 3? It's in 2 quadrants. One is going to be in quadrant 1, and that's going to be pi over 6 plus 2n pi. And then the other answer is x over 3 equals, it's going to be quadrant 3, which is going to be the 7 pi over 6 plus 2n pi. And now if I want to solve this, multiply everything by 3. So when I multiply by 3, the first one is going to be 3 pi over 6. That just reduces to pi over 2, so I'll write pi over 2 instead. And then plus 2n pi times 3, that's going to be 6n pi. So there's one of my 4 answers. The next answer is going to be the 7 pi over 6. That's going to be, multiplying by 3, I get 21 pi over 6. That's going to reduce to 7 pi over 3, just so you know. So I'll write 7 pi over, not 3, sorry, I meant 2. 7 pi over 2. And then that's going to be plus 6n pi as well for the same reason. So there's my left side for the positive values. Now for the negative values, I have to remember I'm going to be in quadrants 2 and quadrants 4. So that means I'm going to get x over 3 equals, it's going to be 5 pi over 6 plus 2n pi. And then the other one's going to be x over 3 equals, quadrant 4, 11 pi over 6 plus 2n pi. Now, in case you're curious, I do have, a unit circle nearby. I have, I literally, I print all these lessons out ahead of time, and I refer to this to make sure I have the right answers. I'm not making mistakes. But in case you're curious, I do not need my unit circle, at all, to answer these 5 pi over 6, 11 pi over 6. I know the unit circle inside and out. I'm not saying you should at this point because it's the summer before the fall and you only do this with me once a week. But what I am saying is you will get to the point eventually where you're even better at this than I am. Hopefully. Well, how is that possible? Is anyone really better than Dan the tutor? Of course not. Who am I kidding? But hopefully you can get one step below me. That's the important part. So anyways, now we multiply by 3 again. You're going to get x equals 15 pi over 6. And that's going to reduce to 5 pi over 2. Plus 6n pi. And then the very last one we have is going to be x equals 33 pi over 6. Both of those are divisible by 3, leaving you with 11 pi over 2. Again, plus 6n pi. There we go. Okay, so the good news is we've done most of everything today. We've gotten through most of the hard parts. The bad news is that, well, we're going to have one more hard thing that we're going to be doing today. And that is, other page. And that is solving basically what we just did with the sine 2x, sine 4x, except now instead of saying plus 2n pi, we're going to be doing from 0 to 2 pi again. Okay? So the good news was at the very beginning of today, there was only 2 answers at the most. Why? Because the 2 answers were either quadrant 1, quadrant 2, quadrant 3, quadrant 4. It was 2 of those 4 quadrants. Now because we're dividing stuff, for instance, we're dividing all our answers by 4, in number 13, for instance, you can get a lot more than 2 answers. As a matter of fact, number 13, I believe, is going to have 8 answers. Yeah, it has 8 answers. That's going to be fun. So what do we do in these cases? When it's over the interval from 0 to 2 pi instead, you need to blank for n. You're going to plug in values for n and write out the solutions. Remember, n is equal to 0, 1, 2, 3. Technically the negative numbers as well, but we're not doing negative numbers today because, just look at this. 0 to 2 pi is only the positive numbers, okay? And it's not just 0, 1, 2, 3. It's that list keeps going forever. And then, as a hint, I want you to tell you to write 2 pi as a fraction with a common denominator. And I did that a little bit today already. I don't know if you noticed. But that's what we're going to be doing to basically add these fractions together. So, I'm going to do number 13. There's only 4 of these today. These hardest ones. And then we'll be done. So, we'll finish right on time, I think. So, first we have sine 4x equals 1/2. First thing I got to do is ask myself, where does sine equal 1/2? This one's easy. I'll get 4x equals pi over 6. I still write plus 2n pi. I still write that. But you're going to see that that's not the final answer. The other solution I get is 4x equals, we also need quadrant 2 because that's where sine's positive, quadrants 1 and 2. So 5 pi over 6 plus 2n pi. And then if I want to solve for x, I have to divide everything by 4. So I'm going to get x equals pi over 24 plus 2n pi over 4, which is the same thing as n pi over 2. Now the problem is, and I'll do the same thing for the right one. So when I divide by 4, I get 5 pi over 24 plus the same thing, plus n pi over 2. Okay, there's my solutions in the form that we just answered a minute ago. But now this is obviously not between 0 and 2 pi because n goes on forever. So here's what I'm going to do. First, I want a common denominator. If I want a common denominator, I'm going to have to multiply this by 12 over 12. And so what that means is x equals pi over 24 plus 12n pi over 24. Let me write out the first few values for n and you'll see what I get. So the first number is when n is 0. you get pi over 24, obviously. The next answer is add 12. Like every time I'm going to add 12 basically, because that's my numerator. And because if you think about it, pi over 24 plus 12 pi over 24 is the same thing as 13 pi over 24. So that's the next one, 13 pi over 24. And now what I'm saying is each solution after this, I'm just going to add 12 pi in the numerator. So for instance, the next number is 25 pi over 24. The next number is 37 pi over 24. The one after that is 49 pi over 24. But hold on a second. How do I know when I'm supposed to stop? Because I'm just going to keep doing this forever. I know when to stop when I get to 2 pi, right? But what the heck is 2 pi with a common denominator of 24? Well, if I multiply by 24 over 24, I get 48 pi over 24. Which means that as soon as I get past 48 pi over 24, including 48 pi over 24, which means that if I get 48 as an answer, I can't include it. That's out of bounds. I have to cross it out. I can't include it. What I'm saying is 49 pi over 24 is out of bounds because we're above 2 pi. We're above 48 pi over 24. So these are my 4 solutions for that first one, that quadrant 1 answers. And now I have to do the same thing with quadrant 2. Oh boy. So x is going to be, the good news is it's the same idea. It's 5 pi over 24 plus 13n pi over 24. So now when I write out these solutions, the first one is 5 pi over 24. And then you just keep adding 13 each time. I'm sorry. I meant 12. That's my bad. That's supposed to be a 12. Sorry. Yeah, I add 12 each time. 12n pi. So the next one's going to be 17 pi over 24. Then I've got 29 pi over 24. Then I've got 41 pi over 24. And after I add another 12, I'm going to be over 48, so I just stop there. And all of these solutions, all 8 of them, are the answer to this question. Crazy. But are there any questions on number 13? Okay then. Now we're going to continue with number 14. Number 14, and this one you actually don't have to write. You don't have to write too small. In other words, I gave you plenty of room for this one, luckily. But it's 2 cosine of 6x plus 4 equals 6. First thing I got to do is I got to get the cosine by itself. That means subtracting 4 from both sides. So 2 cosine of 6x is equal to 2. Then I divide both sides by 2. Looks like cosine of 6x is just going to be 1. Now I got to ask myself, when does cosine equal 1? It's only at one number. So 6x equals 0 plus 2n pi. And again, that's not on a quadrant, so there's only one answer. And then I have to do the same thing as before. I got to divide both sides by 6. The 0 doesn't matter. I can ignore it. But x is going to be basically 1n pi over 3, because that's what it reduces to. And now I just have to plug in values for n. So for instance, when n equals 1, it's pi over 3. Then it's going to be 2 pi over 3. Then it's going to be 3 pi over 3, which that of course just reduces to pi, so I'll just write pi there. Then after that you get 4 pi over 3, then 5 pi over 3, and then the next number would be 6 pi over 3, but since that's 2 pi, I'm out of bounds. Now there's one more answer here that I'm missing. Can anyone tell me what the answer is? The answer is I'm missing 0. How come 0 is a solution? I thought n has to start at 1. Incorrect. N starts at 0. Remember that. N starts at 0, and then 1, and then 2, and then 3. So that's why the answer is just these 6 solutions right here. Any questions? Okay. And now for the last page. I think I gave you enough room because I gave you like all this space. But I'll still recommend writing small because this is a lot. But here's what I'm going to do for the first one. First, I got to divide both sides by -4 to get sine by itself. That means the sine of 1/2 x is going to equal 2 over -4. That's -1/2 root 3. Again, I want you to write that as -√3 over 2 because this we can use the unit circle for. So when does sine equal root 3 over 2? That's going to be in the pi over 3 family. But since it's negative, it's got to be in quadrants 3 and quadrant 4 for sine. So what I'm saying is 1/2 x is equal to quadrant 3 is going to be 4 pi over 3. Again, plus 2n pi. And then quadrant 4 is going to be 1/2 x equals, that's going to be 5 pi over 3. Again, plus 2n pi. And now I need to multiply both these solutions by 2 to solve for x. So x is going to be 8 pi over 3 plus 4n pi. And then the other one is x equals 10 pi over 3 plus 4n pi. Any questions so far? Okay. So again, I need a common denominator here. It's going to be a common denominator of 3, so I multiply by 3 over 3. And I'm going to get x equals 8 pi over 3 plus, that's going to be 12n pi over 3. So in other words, I'm adding 12 pi again each time. The problem is my very first answer, 8 pi over 3, that's out of bounds. How do I know? Because 2 pi with a common denominator of 3 is 6 pi over 3, and already 8 pi over 3 is out of bounds. Now you may be thinking, hey Dan, can't I choose 0? Well, if you choose 0, you get 8 pi over 3, same problem as before. Can you choose -1? I mean, you can use -1, but if you do -1, you're going to get 8 pi over 3 minus 12 pi over 3. And now you got a negative number, and that's already out of bounds again. So in other words, there's no solutions from that side. And that's okay, it just means there's no solutions. But we still have this guy to worry about. X equals 10 pi over 3 plus 4n pi. And if you think about it, for the same exact reason, all these answers are out of bounds as well. 10 pi over 3 is greater than 6 pi over 3, which again was 2 pi, which was my limit. So basically, there are no answers that are going to work. The only thing you can write is no solution. Or you can say no solutions on 0 to 2 pi if you want to be more specific. Because obviously there are solutions, but there's no solutions in this range from 0 to 2 pi. Okay, any questions on number 15? And now just one more to go. Of course, it's the longest one. It's the cosine squared of x over 3 is equal to 1/2. Maybe you've noticed by now that whenever I have, for instance, cosine squared of, let's say, 3x, I get more solutions. And whenever I have x over 3, it's in the denominator, I get less solutions. So maybe you're already thinking I'm going to have less solutions than normal. You would be correct. And if you don't know what I'm talking about, just be prepared when we don't actually have that many solutions here. So here's what I'm going to say. First, take the square root of both sides. I don't like square root of 1/2. I rewrite it as root 1 over root 2. And of course, root 1 is just 1. Then I need to rationalize this by multiplying by root 2 over root 2. We already did this today. Hopefully you remember it's root 2 over 2. It's also plus or minus because we took the square root. It's got to be plus or minus. Don't forget that. So now I've got two potential solutions here. Cosine of x over 3 equals root 2 over 2, positive. And then I've got cosine of x over 3 equals negative root 2 over 2. So first I'll deal with the positive side. I ask myself, where does cosine equal pi over 2? I'm sorry, root 2 over 2. The answer is not pi over 2. The answer is pi over 4. So x over 3 equals pi over 4 plus 2n pi. And I get a second solution too. I get x over 3 equals quadrant 4 is also where cosine's positive, so that's 7 pi over 4 plus 2n pi. And then I multiply both of these by 3. I'm going to get x equals 3 pi over 4 plus 6n pi. And I'm going to get x equals 21 pi over 4 plus 6n pi after I multiply both of those by 3. So now I need to ask myself, common denominator, right? So it's going to be common denominator of 4, so 4 over 4. That's going to mean that x equals probably 3 pi over 4 plus 24n pi over 4. And then the other one is x equals 21 pi over 4 plus 24 pi. 24 n pi over 4. I'll give you a second to write this down. And one thing I'll just remind you, since we want to go from 0 to 2 pi with a common denominator of 4 is going to be 8 pi over 4. Meaning, any answer over 8 pi over 4 is out of bounds. For instance, I see 21 pi over 4 is already out of bounds. And 3 pi over 4 is good, but 24 n pi over 4 is certainly going to be out of bounds. So it looks like the only answer I have from all of those is x equals 3 pi over 4. Now I'm not done yet because I still have to worry about the negative side. I haven't done the negative side yet. First I'll just make sure, I'll go back here, make sure you wrote this down. I mean, if you didn't have time to write it down, you could always watch the recording, I suppose. So, anyways, back here. Now if I want to solve for x over 3 equals negative root 2 over 2, I have to ask myself, what quadrants am I dealing with here? Well, it's definitely going to be quadrants 2 and quadrants 3. And it's the pi over 4 family, which means x over 3 is equal to 3 pi over 4 plus 2n pi. And then the other one is x over 3 equals 5 pi over 4 plus 2n pi. Again, same thing as before. I'm multiplying everything by 3. I'll get 9 pi over 4 plus 6n pi. And then for the other one, I'll get x equals 15 pi over 4 plus 6n pi. And remember what I said. Anything above 8 pi over 4 is out of bounds. That means all of this is out of bounds. In other words, the only answer to this problem is 3 pi over 4. Everything else is out of bounds. So that actually wasn't terrible. And with that, that's going to conclude the lesson today. So just so you know, for the homework, I recommend using the unit circle to help you out. Remember, when you take the square root, it's plus or minus. And remember your quadrants. There's always going to be two answers. In other words, cosine has two positive answers, quadrant 1, quadrant 4, and two negative answers, quadrant 2 and quadrant 3. And the same can be said for sine and tangent for their quadrants. So if you have any questions, please let me know. If not, I hope you have a great rest of your Monday night. Take care, and bye-bye.